Okie dokie. So we are going to be looking at lesson 56 today. We're going to be talking about just a couple of different things. First, we're going to talk about finite and infinite sets. And then we're going to be talking about what it takes to be a member in a set. And then the third thing is a little bit separate from those two concepts. We're going to talk about rearranging an equation before actually graphing it, because sometimes it's not given in a nice, tidy order that we need it to be. So we'll take a look at how to do that as well. Okay, so the first thing we want to talk about is finite and infinite sets. So finite, if you think about the word finite, you think about something being bounded or limited, okay? Infinite would be more without end, infinite. So let's go ahead and fill that in. You're going to notice right at the top here, if something is bounded or limited, we're talking about something that is finite. If we're talking about something that is unbounded or unlimited or without end, maybe you want to add that here, without end. We're talking about something that's infinite. In other words, it goes on and on forever and ever. Okay, this next part here, we're going to take a look at. I'm not going to spend a whole lot of time talking about that because it's really not what we're discussing in this lesson, but this is a way that you might write what's called a set. So let's talk about what sets are first. So we have something, and I'm going to get a blank sheet of paper here to introduce this to you, but we have something known as a finite set, and a finite set is simply a set that's got members in it, which are numbers. A finite set, remember we said, is bounded or limited, and so it could have something like this, 6, 7, 8, 9, and 10. That's just an example. Okay, that would be a finite set of members. An infinite set would be different. An infinite set, since there are no bounds and no end, you might have numbers that look like this. It could be 1, 2, 3, 4, 5, but you'll have those little ellipses, they call them, that go on and on forever. It's an indicator that those numbers are going on forever. And did you ever think about the fact that you could never in your lifetime sit down and count all the numbers infinitely? You would actually end up leaving this earth before you actually had a chance to get to the end. Because why? Because an infinite set of numbers has no end. So if you were going to count all the numbers there are, it could never be possible as long as you're on this earth. So just a little nugget there for you. Okay, so I want to look at a set of numbers here. I'm going to write this down. So let's say we have, 1, 2, 3, 4, 5, 6, 7 zeros. 6, 7. And 4 ones. And 4 twos. Okay, so let's say we're looking at this and we want to designate these numbers as members of a set that we're going to call B. Okay, so we want set B, and I'm going to use these numbers or members to make a set. Okay, so we would write this as B, meaning the set of B is actually, you would say this as B is the set whose members are, and then you would state the numbers that are in there. Now, the interesting thing about this is you see several zeros, you see several ones, and you see several twos. But when you're making a set to include those members, you don't write every single one of those. I only need to write 1 0, 1 1, and a 2, because that indicates that in that set could be many zeros, ones, or twos, but we only have to list them one time. It's not important to have to list all of them, but you do need to list it if it is one that lives inside that set. So how do we say this? We say B is the set whose members are 0, 1, 2. Okay, let's look at another example. Next example, let's look at, let's say we have a set. Wait, let me look here. Okay, so we want to show members of set K. Okay, and we're going to have these numbers 1, 0, 2, 1, 0, 5, 7, 4, 5, and 7. Okay, now the important thing is that when I'm putting these into set K, they do not have to be listed in order. That's not necessarily important, but listing them only once for each number that you see is important. In other words, I have 2 ones, so I'm going to list those in there. I've got 2 zeros, but I'm going to list only one of those. So a 0, a 1. I'm sorry, I think I said that wrong. So if you have several numbers, you only need to list it once. Now, I am going to put these in order because I can see clearly the order that they need to be in. Okay, so you list them inside the set K. So this is saying K is the set whose members are 0, 1, 2, 4, 5, and 7. Now, I want to talk about symbols. So if a number is a member of a particular set, we use a symbol that looks like this. If it is not a member, then we use a symbol that looks like that, but we put a slash through it. It means it's not a member. Okay, and how would we write that? For example, we might say 0 is a member of L, and perhaps it would be 23 is not a member of L. Okay, so that's how we would write something like that to express that information. All right, let's look at another example here. I'm going to have to add another page, I think, so let me go ahead and do that. All right, next example here. Let's say we have the sets A, whose members are 0, 1, 3, and 5. And let's say we have B, whose members are 0, 4, 6, and 7. And let's say we have a set of C, whose members are 1, 2, 3, 5, and 7. Okay, so which are true? And I'm going to give us 3 things to look at here. Is 5 a member of set A? Is 4 a member of set C? Is 5 not a member of set B? So there's 3 questions we want to answer true or false to. So let's look at A here. This A onto the left right here. I'm looking at this column over here. So let's look over here. So 5 is a member of A, true or false? So let's go look at set A. Is 5 a member of that? Yes, it is. It's right here. So this one is true. Is 4 a member of C? So let's go look at C. Is 4 in there? No, it's not. So that one is false. Is 5 not a member of B? So let's look at B and see if 5 is in there. 5 is not in there, and this is stating that 5 is not in B, so this is a true statement. Okay? Now let's look at another one. Let's look at the set L that has 0, 1, 2, and 3, and M, which has 5, 6, and 7, and finally N, which has 0 and 1. Let's look at this again. So how about 6? Is it a member of L? Let's look at L. Is 6 in L? No, it's not. So it is not a member. So that is false right there. Is 0 a member of N? Well, let's go look at N. Yes, 0 is. So that is true. Okay, so that gives you kind of an idea of how to do this. Now let's go up into your notes really quickly. And let's look at these up here. All right, true or false here. 3, I'm looking right here at number 1. 3 is a member of 1, 2, 5, 9, and 13. 3 is not in there, is it? So that is false. 0, is 0 a member of this set right here? Yes, it is. It's right here. So that one is true. Is -5 not a member in this set? That is true. And look at the different things that are put in here. It looks like a file cabinet right there, maybe a sheet of paper or something here. That's a funny set, isn't it? Okay, so it's including a lot of different things other than numbers. But -5 is not in there. So -5 is not a member. So that is true. It is making a true statement when they said 5 is not a member in that set. Okay, you also notice over here some symbols. Really and truly today, the ones we're most interested in is this one right here, okay? Not an element or not a member, okay, or an element or a member, okay? And that's why it's an E, because it's considering it being an element or a number, okay? All right, let's look at number 2 here, but I'm going to move down to my sheet of paper here and move on to the next concept. So the next concept here, we're going to talk about rearranging before graphing. All right, so I'm going to do an example with you here, and then we're going to go back up to our notes. Let me see what's up there. Yep, and we'll do one in our notes. Okay, I'm going to do actually a couple with you. Okay, so let's say that we're given these instructions. This is our first example. It's not in your notes, so you can just watch me. And we're supposed to graph this equation, and we know that if we have an equation that's a linear equation, that means that we can graph this as a line. It's a first degree equation, right? So the exponents that we have, the highest exponent is 1, which means it's a linear equation, which means it can graph as a line on a graph. So the first thing we want to do is we have to set this thing up to solve for y. Why do we do that? Because it needs to be set equal to y. Because remember the function machine? Remember that thing that I used to draw that looks like this? And you always put in a value for x and it spits out a value for y. Remember that? So we want our equation to be set to y because we're going to do a chart in just a moment, where a little table where we can plug something in for x and it's going to spit out something for y. Okay, so let's rearrange this equation so that we have y as our isolated variable. So we're going to move 3x over here. We have 2y equals 4 minus 3x. In order to make y isolated, we have to divide everything by 2. That isolates x, and now I have 2 minus 3 over 2x. Remember, I can write that as 3 halves x. Now I want to just flip these around because we know that there is a formula that's called the slope-intercept. When we're graphing equations, we always have it set up like this, where the x term is here. So let's just move these around. So y equals negative 3 halves x plus 2. Okay, that's pretty standard that we would have it set up this way. All right, so the second thing that we would do is we're going to solve the function. Okay, whoops, oh my goodness. Solve the function, which also means solve for y. Okay, so I'm going to draw a little table here, an XY table. You're going to remember doing this. We've been doing this since 8th grade, I believe, maybe even before that. But anyway, we're going to pick a few values. I'm just going to pick 0, 2, and negative 2, just to give us a little bit of a spread on the graph. If I put a 0 in for x up here, so let's go test it. I'm going to, when x is 0, what is y? When x is 2, what is y? And when x is negative 2, what is y? We're going to use each one of those into this equation. So I have y equals negative 3 halves, but I'm going to put 0 in for x plus 2. Y equals, it's going to end up equaling 2, right? Because this is going to 0 out here. So y is 2. So when x is 0, y is 2. You remember doing these? Let's do the next one here. So y equals negative 3 halves when x is 2. What is y is what we're trying to find out here. So I put 2 in for x. Y equals, oh look, I can cancel out those 2's. Negative 3 plus 2 equals a negative 1. So when x is 2, y is negative 1. How about when x is negative 2? Let's put a negative 2 in there. I'm going to actually multiply this out because I don't want you to get confused by the negative sign. Oops, sorry, that should be a positive. Perhaps I'm going to get confused by it. I'm so sorry. So positive 3 plus 2 is 5. So when x is negative 2, y is 5. Okay, so we now have ourselves some points to put on a graph, don't we? We can actually plot these. So I'm just going to go right down here below it so I can still see my coordinate points that I want to graph. I have an x-axis and a y-axis. And I'm going to go ahead and graph these 3 points. So 0, 2 would be right here. 2, negative 1, be about right here. Negative 2, 5, 3, 4, 5, be about right here. I don't think I have those perfectly spread out, so I'll make the circles a little bit bigger so it looks a little better. Okay, and there. Now I've graphed that equation, and this is what it looks like. Okay, so this is actually that original equation that was right up here is now graphed right here. Okay, but we used a 3-step method to do that. And by the way, the third thing over here was to graph the points. Okay, so I'm going to do one more simple one, and then we're going to build one into your notes. So let's take a look here. I've got to get myself one more page. Add a page. There we go. All right, last example before putting one into your notes. We're going to graph this equation. Y minus x equals 0. Remember the first thing that I said that we need to do is to solve for y. So we're going to need to rearrange before graphing this. That's the first thing. So how do I do this? So let's move x to the other side. Oh, this is going to be a beaut. So y equals x. There's nothing more that I can do here, is there? Now, I could leave the 0 there. Sorry about that. I could leave the 0 there, but you know that that can drop right off. So there's our new equation. The second thing that we're going to do is solve by making a table. Solve the function is what I want to say. So step 1 is to rearrange so that you can solve for y. We'll just use that word rearrange there. All right, we'll pick a few random points, but spreading them out a little bit onto the graph for x. So if I put, now this is easy because think about this. If this is my equation and x is 0, well, what does y equal? Y must equal 0 also. If x is 3, then y has to be 3 because they're equal to each other, right? And so on. So here's our 3 points. This one is an easy one to do, really. Let's go ahead and graph this. -3 is over here. 3 is here. And 0 is here. And there's our line. Missed that center point there. Okay, so there we go. We took that equation right up here that we started with, and we graphed this line right here. Let's go back up to our notes now. Pull your notes right in front of you so we can go ahead and do one so you have it into your notes. All righty, we're going to rearrange 4x plus 2y equals 6 to solve for y. So let's go ahead and write some steps over here. So the first thing we're going to do is rearrange to solve for y. So let's do that. That's the first thing. So we need to isolate y, so the first thing we should do is move 4x over here. We subtract it off both sides. We're left with 2y equals 6 minus 4x. To isolate y, we need to undo the multiplication of 2 by dividing by 2, because we use the inverse operation. Now we have y equals 3 minus 2x. We're going to go ahead and get this in a better order, where we have y equals negative 2x plus 3. Here's the equation that we want to graph. So step 2, we're going to solve the function with a table. And the table is this, x, y table. And we'll pick some random points here as well. I always like to do -2, 0, and 2. If I don't have any given to me to try, I usually spread them out like that. So let's put a -2 in here. So now I'm going to go off down here, just make a little spot where I'm going to write this equation. Y equals -2x plus 3. And I'm going to put in a -2 for x. And I'm going to get -4 plus 3 equals -1. That's the first one. Now the next one, we're going to put a 0 in. for x. And when x is 0, y is 3. Let's do the third one here. Y equals -2, and we'll put a 2 in. I think I made a little mistake over there. Hopefully you guys are screaming. I probably not paying very close attention, and I apologize here, because this actually over in the first equation, look at this. -2 times -2 is a +4. So this should be a +1. So the first one should have been a +1. Please forgive me. All right, so we have when x is -2, y is 1. When x is 0, y is 3. When x is 2, y is -1. Okay, so the third thing we're going to do is we're going to graph this. Graph your points. Okay, and you have a nice graph here. So we're going to take what we found in our table and put it on our coordinate plane. So -2, 1, 0, 3, and 2, -1. Oh, that can't be right. What did I do wrong? Oh, golly. Okay. You know why I know that can't be right? Because it cannot be, it has to be a line. It's a linear equation, so I did another wrong calculation. Not only is it the end of the day, it's also the end of the week as I'm recording this, so I guess I'm having a little struggle. All right. Let me go back to this first one. I had -2. I put -2 in there. I ended up with a 4 plus 3. Golly gee willikers. Okay. This should be a 7. There we go. And this actually should have been -1. But the first one is the wrong one. So let me just get those off there. All right. I hope you guys are checking behind me. All right, so I have -2 all the way up to 7 right there. And then 0, 3, and 2, -1. This looks so much better. There we go. Now we connect our points, and we have made a line. That's our linear equation graphed on a coordinate plane. Okay, so let's look at the 3 practice problems. If you want to...
Mari, are you talking to yourself?
I'm video recording. It's okay. Okay, so we're going to look at letter A together, and if you want to pause the video and try these yourself and then come back and check your answer, that would be great. The first one says we're going to represent the following numbers as being members of set K. I am looking in the textbook on page 231, so we're just going to take that and write it. So we have set K equals, and these are the members or the elements of this set. We have, and remember, they don't have to be in order. That's not what's important. What's important is that you don't list the same number twice. So we have 310, 5095. So 310, 50, which is already listed, 9, and 5, which is already listed. So there's the answer to A. Letter B, we have 4 different sets that we're going to look at, or elements rather. Numbers, we're going to see if these, we have sets given to us as well. So look at letter B. You have sets A, B, and C, and you're going to determine whether these, excuse me, whether these are true or false. So 5 is an element of B. So if you look up at set B, you have 0, 1, 5, and 6. So yes, that's true. 5 is an element of set B. How about 5 and C? Is 5 not an element in C? It shouldn't be, so let's see. Look at C, 1, 3, 4, and 6. So 5 is not an element of C, so yes, that is also true. Letter C, is 0 an element of A? Yes, it is. Goodness, these are all true. And finally, 3 is not a member of C, so let's look at C. C includes 1, 3, 4, and 6 as its elements or members, and so 3 is included, so D is actually false because what it says is that 3 is not an element of C, and that's not true. All right, and finally, C, we are going to graph yet another equation here. So we have 2x minus 3y equals 6. Again, if you want to pause the video to check this out on your own and see what you come up with, you can use the steps that you wrote into your notes. I'm going to go ahead and talk through it. You want to come back and check your answer, that would be fine. Okay, so we're going to isolate y or solve for y. So I'm going to move this 2x. Over here I have negative 3y equals 6 minus 2x. We are going to divide by 3 to isolate y. So we end up with y equals negative 2 plus 2/3 x. We are going to just rearrange this to put the x term first. So we'll have y equals 2/3 x minus 2. All right, now we're going to make a table. I'm going to do that right below here, an XY table. And I'm just going to pull out, again, what I'll do this time is I'll just make them a little easier for my brain at this late time of the day and week, and we'll pull those in there. You could use more if you like, but really and truly, if you grab 3 that are at least spread out a little bit, that's helpful because you want them to be on the graph far enough apart that you can connect your lines, connect your dots to make your line on the graph. Okay, so let's put a negative 1 right in for x. I would have y equals 2/3 times a negative 1 minus 2, which is y equals a negative 2/3 minus, I'm going to go ahead and put this over 3 down here. You see what I did? I need common denominators here. So this would become 6. So I end up with negative 8/3. So this graph isn't going to be all that nice, I don't think. Okay, so I'm going to go ahead and put that into my coordinate plane, or into my table, negative 8/3. I might not even graph that one because it's kind of an awkward finding, but 8 divided by 3 is like, it's a little more than 2.5, so I probably won't even use that one. So I might end up using a positive number here just to see what we end up with. So let's go ahead and put a 0 in for x. This one could be a nicer one because y is going to equal negative 2. I like that one a little better. Let's put a 1 in. Maybe that one will be good too. I don't know. 2/3 times 1 minus 2. Y equals 2/3 minus 6/3 equals a negative 4/3. Yeah, I don't like how these are turning out, but we'll do the best we can getting them on the graph. I'm going to put a 3 in there too because I know that's going to work out nice for us. So I'm just going to change this 2 to a 3. So if I do that, let me scoot over here. Y equals, because I know that's going to get rid of that denominator there. And probably I could have been smart and chosen other numbers that would have done the same thing. But really, we only need 2 points to connect this line. So now I have y equals 2 minus 2, which is 0. So when x is 3, y is 0. Okay, so hopefully you have a little bit of room here that you can make yourself a coordinate plane. If you have one printed, that's even better. X and y. All right, I'm going to just go with 0, negative 2 to start with, which is going to be right here. And I'm going to use 3, 0, which is right here. And really, that's all I need. I'm just going to go with those. And there's my linear equation put onto a graph, okay? So the process is kind of fun, makes sense, it's organized, it's good steps to be able to go from an equation that needs rearranged to solve for y in order to get some points to put on the graph and then connect it to make your line. So I hope that makes sense. If you have questions, please let me know. Thanks for watching.